In order to make a visualization, we need data, and we usually need it in an organized tabular form suitable for plotting. The Pandas library provides easy-to-use data structures and data analysis tools that you can use to make your data easier to plot. An important data structure of the Pandas library is a fast and efficient object for data manipulation called the data frame. The image below is a Pandas data frame. A row represents an observation, and a column represents a feature. Rows have labels called indexes. So for example, this row is the row with index 0. This row is the row with index 1. Columns also have column names. So we have the month column, we have the starting balance column, the repayment column, and so on. Once you create a Pandas data frame, you will more easily be able to manipulate and clean your data. In order to create visualizations, you first need to have data to work with. So in this video, I'll teach you how to create sample data in the form of a car loan table. So what we have here is a car loan of $34,690 with a 7.02% interest rate over 60 months. There are multiple approaches to structure your data into a form acceptable by a Pandas data frame. One approach is by using a nested list, where in the first row, we have the first month of our car payment. So we have one for the month, we have our starting balance, we have a repayment, which is $687.23. We have how much of that repayment is going toward interest. We have how much of that payment is going toward the principal of the loan. And then after a payment, we have how much is our new balance. We have the term of the loan, which is how many months we're going to be paying this loan for in total. We have the interest rate for the loan. And we also have the car type. In this case, it's a Toyota Sienna. And then we also have the column names, which are what I just told you before in the form of a Python list, where we have the month, the starting balance, the repayment, etc. And then once we have the data in a nice, clean format, we're going to press Shift-Enter to run this cell. From here, we're going to use the pd.dataframe method, and we're going to insert our car loans variable into the data parameter and our call names variable into the columns parameter. And then we're going to press Shift-Enter to initialize our data frame. And from here, we're going to press Shift-Enter again, and we have our data in a nice, clean format. And obviously, this is more readable than a nested list. But there's also other ways to do this as well. We could have also structured our data in the form of a NumPy array. And this looks very similar to a nested list, except for a NumPy array is more efficient than a Python list. And similarly, we have the same column names as before. So now that we have the data in a format that we like, we're going to press Shift-Enter. And just as before, we're going to have our car loans variable assigned to the data parameter and our call names variable assigned to our columns parameter. We're then going to press Shift+Enter to initialize our data frame. And as before, we have our data in a nice, clean format, which is obviously easier to look at than a NumPy array. The third approach is to use a Python dictionary. And while this may not seem like as clean of a format to structure your data, there are times when you're already going to have your data in a Python dictionary. It'll just be easier to use that Python dictionary to then initialize a Pandas data frame. So we have our car loans data, and like before, we're going to press Shift+Enter to initialize our car loans variable. And from here, we're going to initialize our Pandas data frame by having our car loans variable assigned to our data parameter and our call names variable assigned to our columns parameter. And then we're going to press Shift+Enter to initialize our data frame. And like before, you can see that we have our payment table, which is clearly an easier to look at format than our Python dictionary. So as you can see, building tables like these aren't all that difficult. However, there are some limitations of these approaches that I'd like you to be aware of. For example, if you have a larger data set, like the entire payment table for a particular car loan, for example, like what I'm showing here, it would be painfully slow to type this out and get it correctly, for one. And two, it'd be very memory intensive. And now that I've painfully typed out this payment table, we're going to run this cell by doing Shift+Enter. And as before, we're going to initialize our data frame. And voila, we have our entire payment table. This is a very tedious approach, and I do not recommend it. I should note that if you don't know what a command does, for example, pd.dataframe, you can always use the inbuilt Python function help to find out what the parameters accept as valid. And that's it. In order to create data visualizations, you need to have data, and now you know how to create it. In my line of work as a Python instructor, one question I often get from students is how do you load your own data? In this video, I'm going to show you how to load CSV and Excel files using the Pandas library. So the first thing you have to do is you have to find out where your files are located. I've provided some exercise files included with the course. So inside the folder, exercise files, inside the Pandas folder, under data, I have two files, car_financing.csv and car_financing.xlsx. In this cell, we have a path to the file car_financing.csv. And what this here is a relative path. So relative to the notebook load_data.ipynb, I have the data folder, and inside the data folder is the CSV file that we want to load. From here, we're going to use the pd.readcsv method to load that file into a Pandas data frame. And I'm going to press Shift plus Enter. And then from here, we can look at the data frame. You can also load files from Excel. Inside the exercise files folder, we have a folder called data, and inside that folder is a file called car_financing.xlsx. And what we're going to do now is we're going to read the Excel file using the method pd.readExcel into a Pandas data frame. And like before, we've loaded the file into a Pandas data frame. I should note that if you need help or if you don't understand what a method does, you can always use the inbuilt help command to understand the documentation for a given method. And then I'll press Shift Enter, and I can see what the readExcel method takes in as parameters. Because sometimes your file may not load as perfectly as you may wish. So that's how you load data into Pandas data frames. And one more note, there are many different file types you can load than just CSV and Excel files into Pandas data frames. If you're curious about what other kind of files you can load, I encourage you to do pd dot and then tab read underscore to see what other kind of files you can load. And there you go. After reading the contents of a file into your Pandas data frame, it's important to examine your data for a couple of reasons. First, you need to assure that you've correctly loaded the data. Second, you have to see what kind of data you have. And third, you have to check the validity of your data set. And I'll go through a couple ways we can do this. So one of the first things you do after loading your data is look at the head and the tail of your data set. The method head selects the top n number of records from your data set. The method tail selects the bottom n number of records from your data set. This is really important to do, as oftentimes your data format could change throughout your data set. Another important thing to do is to check your column data types. You can do this by using the dtypes attribute. One thing we'll notice is that certain columns are ints, certain columns are floats, whereas others can be objects, and you can think of objects as strings. Another important thing to do is to find out how many rows and columns you have in your data set. To do this, you can use the shape attribute, and you see that we have 408 rows and 9 columns. A really important thing to do that is often forgotten is to use the info method, and the reason why this is very valuable is that you can see how many non-null values you have in your data set, as oftentimes data analysis tasks and data visualizations will not work if you have null values in your data set. As you can see in the data set over here, for the interest paid column, we have one null value because we have 407 non-null values versus every other column has 408. What this tells me is that I'll either have to remove the row or fill in the missing data with some sort of imputation technique. In the end, it is really important to remember to verify your data. Use the techniques I just showed you to make sure that everything looks good. When working with large data sets, oftentimes you're only interested in a smaller subset of your data. And that's why slicing is so important. And in this video, I'll teach you how to select columns in Pandas, because oftentimes you're only interested in a smaller subset of columns in your data. And I'll also show you how to use slicing operations in Pandas. I'm working with a car loans dataset where I have the data frame df, and I'm looking at the first 5 rows. Let's say you're only interested in looking at a few columns of your dataset. So let's go over how to use brackets to select just a few columns. What the code here does is we're using double square brackets to only output one column of our dataset. And as you see, I've only pulled out the car type column. Now we can also select multiple columns using double brackets. And let me show you how that's done. So right here, you notice that we have a list within these brackets. So I'm looking at the card type column, and I'm looking at the principal paid column. So I run this, and now I have the card type column and the principal paid column. And notice that when I use the inbuilt type function, that this is still a pandas data frame. One thing a lot of beginners often have difficulties with when working with pandas is if they just have single brackets, they'll end up with something that looks like this. This is called a pandas series. And what this is a one-dimensional array which can be labeled. In this case, our labels are R0, R1, R2, R3, and F4. These are called indexes. And notice when I use the inbuilt type function, I have a pandas series. Keep in mind that when you use pandas series, you cannot select multiple columns. This will result in a key error, as you can see here. And this is a really common error that a lot of beginners run into. And this usually results from people wanting to select multiple columns. And the simple solution to this is simply to use a pandas data frame. In other words, use double brackets. So I have my data frame, I'm selecting my card type column, and I'm selecting my principal paid column. One reason why you might use a pandas series as opposed to a data frame is that with a pandas series, you can select rows using slicing, where you have the series, the start index of what you want to select, the end index of what you want to select. And keep in mind the end index is not inclusive, and this behavior is very similar to Python lists. So I have a pandas series here where I'm looking at the card type column, and this is the entire card type column. Say I'm only interested in, let's say, index 0 up until but not including index 10. In other words, from here to here, I can use a slicing operation. So over here, I have my card type column, and this is a pandas series. And here's my slice, and I'm just selecting from index 0 up until but not including index 10. So from 0 to 9. Keep in mind, you can also select columns using dot notation. However, this is not the recommended syntax. And as you'll see in this cell over here, this can result in an error as there's a space in this column name. Keep in mind that this also fails if your column name is the same as the pandas data frame's attributes or methods. So a safer syntax is just to use single brackets. And lastly, I want to show you the preferred syntax for selecting columns. And this is by using the LOC attribute. And this allows you to select columns, index, as well as slice your data. So over here, I'm selecting all the rows of my pandas data frame. I'm specifically saying I just want the card type column, and then I want the first 5 rows. Similarly, if you just want a pandas series, you just take out the square brackets around your column name. So that's it. If in the future you're presented with a big data set and you want to look at a subset of it, consider slicing. When working with a data set, oftentimes you're only interested in a smaller subset of your data. For example, say I have a car loan data set, and I want to filter out the data to only have a card type of Toyota Sienna with an interest rate of 7.02%. So the first thing I'm going to do is I'm going to look at the first 5 rows of my data set. And while it appears that the first 5 rows are only Toyota Siennas, that doesn't mean the rest of my data set is all of card type Toyota Sienna. The first thing I'm going to do is I'll use the value counts method on the card type column to see what other kind of cars I have in my data set. I have my data frame, I have square brackets, I have the column I'm interested in. I'm going to close those brackets, and then I have the value counts method. When I press Shift Enter, you'll see that I have 120 Toyota Siennas. Say, for example, I was interested in Toyota Corollas instead, I would have to fix the data entry errors because I have 111 Toyota Corollas instead of Corollas. This is a really important thing to take note of, as oftentimes you'll have misspellings in your data set, you'll have errors, you'll have things you don't quite understand, but that's all part of the data exploration process. And what I'll do now is I'll create a car filter, and the way this works is I have a data frame, I have square brackets, I have the column that I'm interested in, I close those single brackets. I have two equal signs because this is equality, and I have the type of car I'm interested in this case, Toyota Sienna. And what this produces is a pandas series of true and false values. There's a couple different ways to utilize this pandas filter of true and false values to get a data frame of just Toyota Siennas. One way is to have your data frame, square brackets, your car filter, which is your pandas series. You close those brackets, and then I'm just going to look at the first 5 rows. The second way is to use a lock attribute, and the way this works is I have a data frame, I have .loc, I have single brackets, I have my pandas series of true and false values, and this colon just means that I want to look at all the columns, and then I'll press Shift plus Enter. And these two approaches are equivalent in the result they produce, but oftentimes the second approach is more legible. As you can see, I have identical outputs for the two different approaches. One thing to keep in mind is that if I try to use the value counts method again on the pandas series for the car type column, it'll seem like nothing changed. And the reason why it looks like nothing changed is because we didn't assign the filter data frame back to the original data frame. And the way to fix this is by assigning the filter data frame back to the original data frame. And now, if you look at the value counts, it looks like we have a filtered data frame. Now that we've taken care of the car type filter, we also have to make an interest rate filter. And if I look at the pandas series for the interest rate column and the value counts for it, you'll see that we have 60 rows with a 7.02% interest rate and 60 rows with a 3.59% interest rate. And what I want to do in this section is filter the data frame to only have the 7.02% interest rate. The code here is a filter that produces a pandas series of true and false values, where the rows that are true are the ones with the 7.02% interest rate, and the false ones will be the rows with the 3.59% interest rate. So I have the data frame, I have single brackets, I have a string of the column that I'm interested in, I close those brackets, I have two equal signs, and then the 7.02% interest rate. And this produces a pandas series of true and false values. What I'm going to do next is I'm going to assign that pandas series of true and false values to the variable interest filter. To utilize my interest filter, I'm going to use the lock attribute followed by single brackets. I'll have my pandas series of true and false values. And then I'm going to select all the columns. And I'm going to take this filtered data frame and assign it back to the original data frame. I'm going to do Shift plus Enter to create the filtered data frame. To check that my interest filter worked as intended, I'm going to look at the pandas series of the interest rate column. I'll use the value counts method, and I'm going to press Shift plus Enter, and you'll see that I have 60 rows with the 7.02% interest rate. In the previous sections, we created a car filter and an interest filter and used the lock command to filter the data by first applying the car filter and then the interest filter. A more concise way to do this is shown below. I have my data frame, I have the lock attribute, I have single brackets, I have my car filter, and then I use the AND bitwise logic operator along with my interest filter, and then I say I want all the columns. And this would have worked just as well as applying each of the filters individually. As you can see, by using filtering, you can get the data that you're just interested in looking at. When you have a data set, it's often the case where you want to change your column names to make them more legible, more understandable, or more easy to program with, or sometimes you want to remove unnecessary columns. An advantage of removing unnecessary columns is it can free up RAM on your computer. It's also a good data science practice. There are two popular ways to rename data frame columns. The first is dictionary substitution, which is very useful if you only want to rename a few of your columns. There's also list replacement, which requires a full list of names. And in my experience, this is more error-prone. The dataset we're going to work with is the car loan dataset, and we'll look at the first 5 rows using the head method. And one reason why I want to rename a column, in this case the principal paid column, is if I try to use the dot notation, where I have the data frame and a dot and the column I'm interested in, this will yield an error. The reason why I have an error is that there's a space in my column name. This would have worked if I had single brackets and a string of the column name I'm interested in and close brackets. However, I still want to fix this, as someone else could run into the same error with this dataset. One approach is dictionary substitution using the rename method. And the way this works is I have my data frame, I have a dot, I have rename, and I have columns here because I want to rename my columns as opposed to an index. I have the original column name, in this case, starting space balance, and I want to rename it to starting underscore balance. Additionally, I want to rename the interest paid column, the principal paid column, and the new balance column. And after I rename the columns, I want to take that data frame and assign it back to the original data frame. And now you can look at the data frame after renaming columns. And as you see, there's no longer a space between many of the columns. There's another approach to renaming columns, and this is through list replacement. In the case of the code below, I want to change the month column, where it starts with a capital M, to a lowercase m. However, with this technique, I still need to list the rest of the columns and assign it back to the df.columns attribute. And now, as you can see, I have a lowercase m for the month column. There are also times where you may want to delete your columns. Approach one for doing this is to use the drop method, where I have the data frame, I have .drop, I'm specifying that I want to drop my columns. In this case, I only want to drop the term column, but keep in mind that using this approach, you can drop multiple columns at a time. And now looking at the data frame, you can see that I no longer have the term column. The second approach to deleting columns is by using the del command. In this case, I'm going to delete the repayment column. As you see below, I no longer have the repayment column. And that's it. The next time you find that you want to rename your columns or delete them, consider some of these approaches. When working with a dataset, it is often a good idea to compute summary statistics. Summary statistics can tell you about your outliers, if your data is symmetrical, and how tightly grouped your data is. For the car loan dataset, where we have a payment table for a $34,690 loan at a 7.02% interest rate for a Toyota Sienna over 60 months, it would be interesting to find out how much total interest paid would be over the course of the loan. For this, we're going to use a sum method. And what the sum method does is it sums the values in a column. And the way this works is I have the name of the data frame, df, I have single brackets, I have the column I'm interested in this case, interest underscore paid, closing the single brackets, and I do .sum. And what this gives me is the total amount of interest paid over the course of the loan. And as you see, over the course of the loan, the interest paid is $6,450.27. You can also use the sum method on an entire data frame to sum across all the values across all the columns. While the sum for the interest paid column is what we had before when we just summed across the interest paid column, the car type column seems to be a bit different. And the reason why this is the case is if you recall with Python, when you add two strings together, they concatenate. It's important to note that if you ever don't know exactly what a method does, I encourage you to use the help method, where you have help, open parentheses, the name of the data frame, in this case, df, open brackets, the name of the column, .sum, shift plus enter. The way the sum method works is it sums down all the values in a column. However, by default, it ignores all NAs or null values when computing the result. So if this interest paid column had any NAs or NANs in them, it ignored them. And that's why it's always important to know exactly what a method does, or an aggregate function in this case, as our sum potentially didn't include any NANs. And the way to check if you have NANs in your data frame is by using the inbuilt info method. And as you see here, I have one NAN in the interest paid column When working with a dataset, it's often a good idea to use aggregate functions on your various columns. This can tell you how well grouped your dataset is, what your outliers are, and potentially useful information, like how much interest you'll pay over the course of a loan by using the sum method. When working with a dataset, you'll often run into missing values. Values can be originally missing from a dataset or be a product of data manipulation. In pandas, missing values are typically called nan or none. Missing data can hint at data collection errors, indicate improper conversion or manipulation of data, or they can actually not be considered missing at all. For some datasets, missing data can be listed as 0, false, not applicable, entered an empty string, among many other possibilities. This is a really important subject, as before you can graph data, you need to make sure you aren't trying to graph some missing values, as that can cause an error or misinterpretation of the data. And in this notebook, we'll see where missing data can cause misinterpretation of our results. The first thing we're going to do is we're going to use the car loan dataset, and we're going to identify how many missing values we have by using the pandas info method. So I have the data frame here, and then I have the info method. I'll press Shift Enter. And then as you see here, for every other column except for interest paid, I have 60 non-null values. But for the interest paid column, I have 59. This means I have one nan value in that column. This will cause a problem. Two common methods to indicate where values are missing are isNA and isNull. They are exactly the same methods, but with different names. The reason why this is the case is in the R language, NA and null are two different things. This is to make R programmers have an easier time when working with Python. I tend to prefer isNA, as this tends to be similar in naming to other Python methods. As you see in the code over here, I have the pandas series interest underscore paid. I'm using the isNA method, and what this does is this is producing a pandas series of true and false values. It will be true where I have a nan value, and it'll be false where I don't. I'll then press Shift and Enter, and as you see in the first 5 rows, I don't have any nan values. The next thing I'm doing is I'm assigning this true and false filter to the variable interest underscore missing. And the reason why I'm doing this is I want to take that filter and eventually use it to isolate my missing data. What the code here is doing is I want to look at the row where I have the missing values. And what you see here is I have a missing value in the interest paid column. This will be a problem for later. It's important to keep in mind they can also use the not operator to negate the filter so that every row that's returned doesn't have a nan. And as you see in the pandas data frame, the row with index 35 is no longer here. It's important to note you'll often see code similar to what you see here. What we have is that same pandas filter of true and false values, and then after, you have the aggregate function sum, which then sums all the true and false values to produce a result. The reason why this works is in Python, Booleans are a subtype of integers, where true are ones and falses are 0. So in the code here, I essentially have 1 plus 0 plus 0. And the reason why I have a 1 here is that I have one nan in the interest paid column. When working with a dataset, it's important to identify your missing values, as missing values can cause data misinterpretation errors or even cause you an error when you try to graph your data. Once you've identified missing data, it's really important to either remove that data or fill in the missing data with a reasonable value. This is a really important subject, as before you can graph data, you need to make sure you aren't trying to graph some missing values, as that can cause an error or cause a misinterpretation of the data. We're working with the car loan dataset, and the first thing we're going to do is we're going to utilize the info method. And what the info method does is it shows us how many missing values we have in each of our columns. And as you see, we have 60 non-null values for every column except for the interest paid column. This means that we have one null value. There are a couple different ways to deal with missing data. The first way is simply to remove the missing values. And in pandas, you can remove the missing values by using the drop NA method. And what the code here does is I have a pandas data frame from index 30 up until but not including index 40, and I'm dropping the rows where I have any NaN values. And as you see here, I don't have a row at index 35 because I had a NaN value here. The other way to deal with missing values is simply to fill them in, and there are a variety of ways to fill in missing values. The first thing we're going to do is we're going to look at where the missing data is located by using a pandas series and then slicing it to look at indexes 30 up until but not including index 40. As you see here, I have a NaN at index 35. The first thing we're going to try is we're going to try to fill in the NaN with a 0 by using the fill NA method. The reason why filling in a NaN with a 0 is often not a good idea, as originally the NaN could have been something else, a 0 could help you misinterpret the data. It's just one option. The other method we could use is to fill in with the backfill. And the way this works is perhaps better to show you. Where at index 35 before, I had a 0 or a NaN. Now I have an 89.77. This is because the index after it was an 89.77. This is very commonly done with time series data when you have a missing value. Another way is to forward fill in your value, and this is also done with time series data. The difference between backfill and forward fill is backfill takes the value after the missing value and inserts it at the value that's missing. And what forward fill does is it takes the value before the missing value and inserts it where the missing value is. The reason why you use one versus the other is really dependent on your domain knowledge and your application. This is also a current area of research. It's called data imputation. Another way to fill in missing values is through linear interpolation. And what this does is it uses a linear model to fill in the missing value. And as you see here, this 93 is between the 96 and the 89. What the code here is doing is I'm finding the total interest paid over the course of a loan by using the sum method. And I should note, the sum method doesn't account for NaNs. And as you see here, this is the total amount of money paid toward interest over the course of a loan. It's important to keep in mind that the sum method, by default, ignores NaNs. So after we fill in a NaN value with a real value, this might change. What the code here is doing is this is producing a Boolean array of true and false values where I'll have a true value where I have a NaN and a false value where I don't. And I'm assigning it to the variable interest underscore missing. From there, I'm utilizing the LOC operator and filling in that missing NaN value with the value 93.24. Now, when I sum over the entire column, I'll get a different number. This is perhaps more accurate, and I should note the value of removing or filling in your data is that oftentimes you get more accurate calculations. In this case, the reason why I filled in the value with 93.24 is because I knew what the actual value should have been. This is due to my domain knowledge of loans. For whatever application you're working with, it's often best to try to get the most accurate value to fill in for your missing values. And as you can see here, we don't have NaN values in the data frame anymore. Once you've identified your missing values, removing them or filling them in often gives you more accurate calculations and makes your results more interpretable. When working with Pandas data frames, you'll oftentimes find you want to convert them to NumPy arrays or Python dictionaries. The reason why is because certain libraries prefer NumPy arrays or Python dictionaries as inputs to their methods, as opposed to Pandas data frames. In this video, we'll work with the car loan dataset again, and we're going to look at the first 5 rows. There are 2 ways to convert Pandas data frames to NumPy arrays. The first approach is to use the to_NumPy method, and what this outputs is a NumPy array. The second approach is to use the values attribute, and this also produces a NumPy array. I should note that either of these approaches works just as well as the other. You can also convert pandas data frames to Python dictionaries. You can do this by using the to_dict method. And the reason why you'd want to do this versus convert your pandas data frame to a NumPy array is oftentimes you're interested in preserving the indices of your pandas data frame. In this video, we've gone over how to convert pandas data frames to NumPy arrays and Python dictionaries. The practicality of this is that sometimes certain libraries don't accept pandas data frames as inputs to their methods. When working with pandas data frames, it is often a good idea to export them to either CSV or Excel files. This is because it is a great way to share your results with others. In pandas, you can export your data frame to a CSV file by using the to_CSV method. In this case, I have a relative path where inside my current working directory, there's a folder called data, and inside that folder is where I'm exporting the CSV file. The parameter index equals false just means I don't want to export the pandas data frame's indexes. You can export your data frame to an Excel file by using the to_Excel method. And in this case, I have a relative path where inside my current directory, there's a folder called data. And then inside that folder is where I'm writing the XLSX file. The index equals false parameter just means I don't want to have the indexes from my data frame export to the file. And keep in mind, if you ever don't know what a method does, you can always look them up using the help command. In this case, I'm looking up the toCSV method. In this video, we've gone over how to export your pandas data frames to CSV and Excel files. Keep in mind, it's also a good idea to check your exported files in the sense that sometimes when you export a file, it may not always be what you expect.